So this is about the first part of the talk is about integrative model, an example of the model structure. And then I will speak about the analysis of read, which is one element in the integrated model. And then as well about herring, which is an important species, example species. In our case, I will show what kind of losses society has experienced due to overfishing. Integrative model is about linking the different policy areas of EU common agriculture policy, especially then as well IMO, oil spill management, and then common fisheries policy, fisheries tools, and looking at the combined effects of these different policy elements. In the case of the eutrophication, we have applied those management actions which have already been agreed by the society policy action plan targets, and as well looking at the non-perfect implementation, that if in a case that only 50% of the reductions would have been obtained. And in comparison, we look at as well on the national targets of Finland. In the case of the oil spills, we look at the different ways to reduce the probability for the spill, improved VTS alarm system, and different piloting options for the Gulf of Finland as well. In the case of the harvesting, which is an additional risk caused by the society for the species concerned, we look at the fishing and or hunting mortality levels, the current situation, total closure, which is an extreme thing to do, and then the highest and lowest observed levels. And we look at these risks for some species-specific, by some species-specific models, which are then risk indicators. But this starts from the eutrophication part, where we look at the inner archipelago, open sea, and outer archipelago. We have Water Framework Directive, and then we have the HELCOM Policy Action Plan objectives, and they actually, to some extent, they are different from the point of view of the decision making. It's easier to reach the Water Framework Directive than the HELCOM objectives, and we look at the different elements of these, how the different policy options impact the different biological and ecosystem elements. In the case of the oil spills tools, we have been using results from our ongoing project, where we look at the possible ways to impact the collision and grounding probabilities of the vessels, and these reflect later on to how likely it is in the future to have oil exposure on the coast. An important part of this is, for example, the location and especially the season of the year, but we don't know that in advance when the accidents will happen. Then a first-hand reaction could be taken as well in the case of the several risks. You can think that the more risk comes from the eutrophication, the more you should do in the fisheries management, because by that you help the populations to reproduce more effectively in a case that the environment is not in a good shape. So these are the hunting management for the common eider is the other option. And then we look at the species-specific impacts. The Baltic herring is in a hero here. But all this is done with probabilities. So, for example, we can estimate with the model what is the probability to reach the Water Framework Directive's different status classes by the different actions. We cannot promise for sure by the science that what will happen, but we can look how well we can predict what will happen, and this is obtained by the probability distributions, how likely it is to reach the objectives. This is the way how we have used the three-dimensional modeling system, estimates of the decrease of the algal biomass. The more blue is the color, the bigger is the reduction in the biomass. On the left-hand side, we have the Finnish national targets. We can see that only a couple of percentages is obtained by the national management actions. But in a case all the countries come along, we go to the right-hand side, and then especially the already implemented reductions in this year implemented reductions in St. Petersburg have a major impact on the water quality, and relatively big reductions can be seen. And these are then provided to the integrated model. There are different water framework directive areas along the Finnish coast, and it is as well a question that which of the areas should be used as a criteria when saying that how much reduction should be carried out, because different areas react in a different ways. The READ is perhaps a new topic for the scientific analysis. There are not that many, at least wider scale modeling analysis done so far. In order to think of how important this problem is seen by the stakeholders, we made a questionnaire to people living along the coastal areas of Finland. Eutrophication was certainly seen as the most important one, risk of the oil spills as the second, but spread of the READ was seen as the third biggest one, for example, before the climatic change. When we asked that how much the READ has expanded in your close by areas, more than half of the people thought that at least increased somewhat or increased a lot. In this analysis, one of the starting problems is that at least in Finland you can say that the READ has an impact on the property values of the coastal areas. It's altering the habitats. There are causalities related to the eutrophication, and we created a simulation model by which you can go over the time. And then these results are transferred to the risk model. Now I will just simulate the changes over the time, which show how the model works. This is done for the whole Gulf of Finland. For the herring, we estimated that the total loss of the values to the society are 440 million in the history. This is what would have been obtained in a case that optimal policy would have been followed. In the end, I just want to say that an important question here for the science is that how much we can really manage with the different tools, and what we should know more in the next bonus call, for example, more about the causal dependencies in the system to have the effective management. Thank you.
Thank you.